Good everyone, welcome to my YouTube channel. Today I'm going to teach you how to use Tekla Tedds to design a steel beam carrying different type of loads. So if you look at my screen, you will notice that we have a variable distributed load and uniformly distributed load on a particular beam. So the question says provide a universal beam section to carry the load above using Eurocode. So in our previous video, I told you that when you see this kind of simple problem, is the fastest and best software to analyze and design this kind of problem is Tekla Tedds. So I'm going to open my Tekla Tedds, go to new document, then look for beams. Then go to steel beam analysis and design. Choose Eurocode. If you are using BS, you can choose BS. If you are using America or Indian code, you can actually change this software to your code, to your country code. So I'm using year 1993, that's the Euro code. I click calculate. So go to geometry, put the span of the beam. So if you watch this beam, you find out that what we have here is 4 meters. 2 plus 0.6 plus 1.4 will give me 4,000 millimeters. Click OK, then loading. So this software calculates self-load automatically, so self-weight is always there. Then what I will do now is to add my imposed loads. I'm going to add, leave it to permanent load, but change the load type to partial variable distributed load, partial VDL. So I'm going to add the first load here is the load on the upper side, or the one close to the origin of the beam. Then the load here, load 2, is the one going to the right side of the beam. So the origin of the beam is support A, that's our left hand side. That's what I'm going to put here. So we have permanent load, that's GK 6.7 on the origin of the beam, left side, and the right side is 2.1, 6.7 and 2.1. So I'm going to put my permanent 6.7, then the end, that's load 2. Load 2 is what? 2.1. So my position for load 1 is 0 point. That's the starting point. For position for load 2 is 2 meters. So 2000 mm. Okay. So the software is actually drawing it. So you are seeing what we are doing here. I'm going to add another load and give it variable load. Partial VDL, load 1 and load 2. So I'm going to select my load 1 and load 2. Load 1 is 8 meters, 8 kilonewton per meter. Load 2 is 3. So I'm going to put 8, put 3, position 0, position 2 meters. Okay. Then add another load. This time around, I'm going to use partial UDL. Permanent load. What kind of load do we have? 5.3. That's our load value. 5.3. So the position is where? We have 2 meters, 2.6 here. So the starting position is 2.6 to 4 meters. So 2.6, 2,600 to 4,000. So add another load, variable load, partial UDL. Load value is 7.5. 7.5 from 2,600 mm to 4,000 mm. So we have finished putting our load. So I'm going to click OK. Load combination for Eurocode. Permanent load is 1.35. Variable load is 1.5. Load factors. So I click OK. So if you watch my previous video, you understand what I said about this. So I'm going to click none. So I'm in Nigeria, I'm going to select S275. If you are in UK, you're going to select S355. So in Nigerian markets, what they normally have, grade of steel they normally have is 275. So if you are in Nigeria, I advise you to select this, because if you use this S355, you might not see it in your market. So S275 for those in Nigeria. Then everything passes, because I have the software have a higher section here, which is not economical. So you're going to click to section, go to UB section, select the smallest. If it doesn't pass, you increase. It does not pass, so I'll select the higher one. So this one passes. Okay, it doesn't pass for buckling moment. I'll go to 178.102.19 and select. So it passes. Go to design. So span deflection denominator 3.6. So when you are designing for this deflection criteria, I explained it in a previous video that if you are designing a beam, a new structure that requires a beam, leave your deflection criteria to only variable load. But if the beam is to carry an existing structure, if the beam is to carry an already existing structure, add the permanent load of that structure. So now I'm assuming that my beam is a new beam and is not carrying any existing structure. So any structure that will be on top of it is going to be a new build. So I'm going to remove permanent. I'll click OK. So that's it. Everything passed. I'll click finish. Okay, see, this is our design. This is how the calculation sheet look like. So everything passed. Deflection passed. Maximum deflection does not exceed deflection limits. So thank you for watching. Watch out for my other videos on structures and even architecture. Thank you. Have a nice day.